Hello guys, I hope everybody is fine. In today's video, we will be discussing about variants of Turing machine. So what are the variants of Turing machines, or there are many variety of Turing machines which are available that will be discussed in this particular video. So let me just overview with the basic Turing machine that we have studied, which is normal Turing machine, and the same description is there in the description box. And if you have not watched that video, kindly watch this video before you are covering this particular video. So normal Turing machine had an infinite length tape, right? So it had infinite length tape, then it had a tape head which is pointing in various directions, whether we are moving in the right direction or whether we are moving in left direction. And obviously it had a finite control unit. Like we have an infinite tape where on the left side, two-way infinite tape was there. Apart from that, we had various blank symbols, right? This was an infinite tape, and if we are reading some symbols, whether it is 0, 0, 1, 1, so everything was controlled by a tape head, which is acting as a pointer. And yes, we had a particular finite control unit because we have to process one by one. So whether we are processing 0, then 1, and then 1. So we had this kind of thing, and this was a tape head that we had which is pointing in either left direction or right direction. Now, considering this scenario, there are various kind of variants which are explained in this video. So for one of the variant that we will be discussing is multi-tape Turing machine. So as the name suggests, multi-tape, so it means we are not going to be limited with one tape like we discussed in normal Turing machine. We are having multiple tapes, and if we are having multiple tapes, like this is, for example, this is tape 1, and let's say this is an example which is example with a tape 2. So we had two tapes or multiple tapes are there. They are having their own read and write head. Like they are also having, this is having a read write head here. This is having a read write head here. So it means what kind of things that we need to understand in multi-tape Turing machine. It will have multiple tapes having own read and write head, right? So again, this will also have a transition function. So now your transition function is not going to behave the way it was behaving in normal Turing machine. Now your transition function will have the states, right? Now, because you're having multiple tape, which is tape number 1 and tape number 2, so we will have the inputs from both of them. So I'm taking the inputs from both of them. Considering A, it is having the string from tape 1 and tape 2. It will generate Q. It will give us A power N, and obviously it will provide us whatever the inputs or whatever the operations we are performing with the left and as well as right functions. So it means this will perform the task. It means you are going to take input from tape 1 as well as tape 2. So when we are taking inputs from tape 1 and tape 2, subsequently, we are going to have an output state. If this is my input state, this will be my output state. And it is going to perform the operation whether you are moving in left direction or moving in right direction. I'm just taking a very simple and basic example of multi-tape Turing machine where we have a state, let's say Q naught, that is one state. And this is for tape number 1. Tape number 1 is A, B, let's say C, and tape number 2 is M, N, and let's say O. So if we are performing a particular operation, the transition function says that Q naught is given A as well as M. So this is my tape number 1 and this is my tape number 2. So it means what change we have done, instead of giving a single input, we are taking two inputs at a time. Two inputs means from tape number 1 and tape number 2. Tape number 1 input is A and tape number 2 input is M. And it will result in two answers, obviously, because when input is given, there will be an output. Let's say they go to Q1 and this A is changed to X and this M is changed to, let's say, Y. If A is changed to X, let's say it has gone in left direction, and M has changed to Y, let's say it has gone in right direction. Right. So eventually what happens is that your Q naught is changed to Q1, your A is changed to X, right? So it is like this, and your M is changed to Y, and we have N and O. So clearly this tape might have moved in left direction and this tape might have moved in the right direction. It depends upon what kind of inputs you are giving. So it means you are giving a state, your input, along with what kind of output they are generating and where it is actually going. So input is given from tape 1 as well as tape 2, and output we will have from tape 1 and tape 2 along with the direction. So it means Q given A par N is giving us Q A par N along with where they are moving. So this is the scenario with multi-tape Turing machine, right? So this is one scenario of multi-tape Turing machine. Now, my second important part is, this is one variant of Turing machine. The second variant of Turing machine is second part, which is non-deterministic Turing machine. So guys, what is non-deterministic Turing machine? So we have discussed deterministic Turing machine. So what is non-deterministic Turing machine? Again, guys, it's very, very simple that if one Turing machine is given one input, or when one state is given one input, if it produces more than one output, means 2 raised to power k, that is more than one for sure. Provided Q value is not 0. But again, even if it is the whole scenario, so Q given any input, it goes to 2 raised to power Q along with the input of left and right. So the point over here is a single input. If it gives output 1 or output 2, it is clearly a non-deterministic Turing machine. Let's say if I'm providing one scenario, A is given X and we are moving in Q1. Similarly, when A is given, it can change to Y and it move in left direction, it goes to Q2. So simply one input, A is given, and we have multiple output states Q1 and Q2. This is non-deterministic Turing machine. So we have the third scenario. And the third scenario is so we have the next topic, which is multi-head Turing machine. As the word suggests, multi-head. Multi-head means that you are going to have certain number of heads and number of heads will point to a single Turing machine. Let's say your Turing machine says M N O P Q R. So this is my input string, and followed by we have blank symbols and blank symbols over here. So we have your head number 1, head number 2, head number 3, and head number 4. So head number 1 is pointing to M, head number 2 is pointing to O, head number 3 is pointing to P, and head number 4 pointing to Q. So there are multiple heads, right? So instead of having a single head pointing to various symbols, we have multiple heads pointing to different variables. So it means multiple heads, right? Each head points to a single input symbol. So whatever direction they want to move, whether they have to move from left or right, right? So these actually will be placed in tracks. So all your inputs will be placed in tracks. So how they will be placed? Like for an example, your head number 1 is pointing to M. So if M is the very first variable of the string, so there are how many string variables? 1, 2, 3, 4, 5, 6. Let's say 6. Considering this is blank and this is blank too, right? So there are 6 variables, which is M, N. We have 6 variables: 1, 2, 3, 4, 5, 6. So we have like this. So there are multiple tracks. So how many tracks we had? 4 heads. So we had 4 tracks, right? So if M is the very first variable out of this, so what we are going to have in this particular scenario, for M, I'm putting it as 1, right? For all other variables, I will take it as blank, right? Similarly, if H2 is pointing towards O, right? So O is the third variable, so I'm putting third as 1, and for rest, I will put it as blank. Probably because if there is head 2 is not pointing towards N, so I'm putting everything as blank with particular values. Now head 2 is pointing towards O, so O is the third variable, so rest I'm putting it as blank, right? Same applies with your head 3, which is pointing towards O. 1, 2, 3, 4. So, right? So we are putting like this. So H4 is pointing towards your fifth character. So I'm putting blank, 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 and 1 blank. So subsequently, guys, how I filled it up, your head 1 is pointing towards M. So M is actually the very first variable. So that means H1 is pointing towards first variable, and first variable I put it as 1. So wherever variable is existing, I've put up 1 here. In the second, H2 is not pointing towards N. So I'm putting all the variables as N because it is not pointing towards it. So N will not do anything. So head 2 is pointing towards O. So O is the third variable. So 1, 2, and 3, third variable is there. Head 3 is pointing towards P. So that is the fourth variable I put up here. Fifth variable I've put up here. So these all multiple tracks are there. So it means it means that whenever multi-head Turing machine works, it works on various inputs, right? So the inputs are taken in the form of tracks. So whatever number of inputs are there, that many number of tracks we will have. So for this is for M, this is for N, O, P, Q, and similarly you can draw for R. So this is multi-head Turing machine. Next Turing machine that we have is your offline Turing machine. Guys, if I talk about offline Turing machine, you need to remember this thing. Offline Turing machine has various inputs of, but firstly, you need to understand there will be two tapes that will work. One tape is meant for your first tape is meant for read and write. First tape is meant for read and write. Actually, the first tape is meant for read operations only. So it will just take all the number of inputs, means read all inputs. And the second important part is it contains the input. The second important part, second tape is meant for performing read and write operations. The first tape is meant for read operations, and second tape is meant for read and write operations. So it means your working of offline Turing machine is that if we are having ABCD as the input, so first control unit will be performing the read operation task. And if there is any operation that is supposed to be performed, whether we have to read or write, we will use FGHI. So this is your write operation, which is done by your second tape. So whatever answers that you need to possess, all are firstly read, and then the operations is done by your second machine. So second machine is actually the machine that performs all the write operations which are there. Okay, so it will also read and perform the write operation accordingly. Last Turing machine is your multi-dimension Turing machine. Guys, multi-dimensional Turing machine, if we have to basically analyze in the form of definition, that your inputs will be processed instead of a tape. They will be processed like checkboard, means your input will be processed in multi-dimension. So it means if this is row number 1, this is column number 1, it can be row number 3 and column number 2. So they are processed like this. So again, your tape will be processed in form of chairs, where you can easily find the output, or if the transition function would be any input given any particular any state given any particular input, it provides output state, but also performs read and write operation. uh, but they will also go in different direction, whether you are going in row wise or you're going in column wise. So that's how it actually works. So that is the whole scenario. These are all variants. So in this video, I completed 5 variants. Multi-tape, instead of single tape, we have multiple tapes. We have completed multi-head, or we firstly did a non-deterministic. We completed multi-head. or multi-track Turing machine. Then we did offline Turing machine. One is for read and second is for read and write both. It is also a multi-tape Turing machine, by the way. And last not the least, multi-dimension, where we have to give the answer for row as well as column where the output is going to be stored. So these are all Turing machines. If there is any doubt, you can always ask me in comment section. Kindly like, share and subscribe. Thank you very, very much for your support.